always doing?
Going in and out of the cell.
If they're around the cell, they're going in and out of the cell. So what does that tell you molecules are always doing? Moving. Constantly moving. Why are they constantly moving and bouncing around? What are they searching for?
An electron for the outside area.
An electron to either complete them or to give away so that they're more stable. Okay, they're constantly looking to react. Now, this reason is why molecules are always moving in and out of the cell. This and another reason, okay? There's two ways molecules will move in and out of the cell. One is called passive. What do you think that means? Passive.
No energy required.
There's no energy required at all. It's like a natural flow. Think of passive transport as a transport, like if you're in the ocean and the waves are moving, what direction do they move? Towards the shore, right? So if you lay down, where are you going? Towards the shore, okay? Now if you want to go out, what do you need to do? Swim. You're going against its natural channel. So passive is like a natural channel for molecules to move. It's the way they should move. It's how it's meant to be. Anybody know in which direction that is?
Inside to out.
Nope. That's a good thought. Sometimes passive is from out to in. Why? What are molecules seeking? Raise your hand.
Electrons so they go inside the cell.
Yes. So where are they going to move?
From where there's a lot of molecules to some molecules.
From where there's a high concentration of molecules to where there's a less concentration. That means from more to less. Here's a cell. Here's some molecules. This is the outside of the cell. If passive transport is going to occur, in which direction are my molecules going to move? Why?
Because it's more concentrated.
It's going to move out because there's more inside than there is outside. When is the movement going to stop? When they're almost equal. That's what it's seeking. It's seeking to have balance with its external environment or the other way around. All right, there's three types of movement that involve passive transport. Anybody know what they're called? Osmosis is one of them. What does that mean?
They move with the water.
It's water moving in which direction?
Into the cell.
In which direction?
Into the lake.
In which direction?
From the lower,
From what?
from high to low.
From high to low. That's it. What's diffusion? No, this is still a type of passive.
Spreads out.
It does, because it's moving from high to low. End of story. Any type of passive transport is going to be the movement of molecules from high to low. Now this is a type of diffusion. So is osmosis. What does the word say? If you read that word facilitated, what do you think that means? What does facilitate mean? Help. Something is going to help molecules go from high to low. What do you think it is? What could possibly help a molecule move?
Lipids.
Good answer, but no. What else? He's on the right track.
Yeah.
No, we're in the cell membrane.
Oh.
No, exactly. So here's a video, I believe, of osmosis.
Diffusion is the net movement of molecules down a concentration gradient. This process allows small molecules, such as oxygen and carbon dioxide, to cross the plasma membrane. Most polar molecules, such as sugars and proteins, cannot freely cross this lipid membrane. Although water molecules are polar, they are small enough to pass through the membrane freely. This special case of diffusion, involving water molecules across a membrane, is called osmosis. If a molecule, such as urea, is added to one side of a membrane, it will not be able to diffuse across the membrane because it is both large and polar.
So urea can pass. Remember the membrane is selectively permeable. Some things can pass and some things can't. So what do you think is going to happen to the side where the urea is? They can't pass. Okay, water's going to move always. What's going to happen to the side with the urea?
All the hydrogen molecules are gonna be.
Okay, that's what's happening to water. My question is what's going to happen to the side with the urea?
They stay there.
They stay there, and if they stay there, what's going to happen to them?
Water's gonna go to the other side.
Water's definitely going to move, but you're not seeing the picture. If urea is here, what's going to happen to urea if it's in the presence of water? It's going to what?
Mix.
Mix. It's going to react with water. So now the concentration of water on the right is less than on the left. So in which direction is water going to move?
Left or right?
From high to low, which means from where to where? From the side with urea or without? Where are we starting?
With urea to the side without.
No. It's going to move from the side without urea to the side with.
So it's gonna go towards.
Watch the first. Exactly.
Because of its polar nature, it will interact with other polar molecules such as the water.
Do you see how it's reacting with water? So now the concentration of water is less on that side. And water always moves from what? High to low, always. Osmosis is always from high to low.
This interaction reduces the number of free water molecules on the right-hand side. With fewer free water molecules on the right-hand side, there is now a net movement of water molecules down their concentration gradient to the side with the urea molecules. Because more water molecules are moving into this area than are leaving, the water level on the right side will rise. If the osmotic concentrations of two solutions are equal, the solution
What do you think is going to happen now if they're equal?
Gonna stay.
Good. They're not going to stay because I already told you molecules are always moving. So the movement is going to go
are
back and forth.
isotonic. However, when the solutions have unequal osmotic concentrations, the solution with the higher concentration of
We'll get to that. Okay? All right. All right, I'm just going to give you one more, actually.